Emerson Marsh.
I'm Anushka.
I'm Claire.
I'm Giuliano.
Today we're going to find out what the best method to do a cartwheel is. In this speech, we're going to get people from this to this. And we're doing this to answer an important question, which is, how do people learn new things? This is important because every day we have to learn a bunch of new things. And if we find out what the best way to learn new things is, then we can learn new things with a lot less energy and stress needed. Now we're going to answer our question with our experiment.
So for our experiment, we had a total of 3 methods that we used. One was video, one was self-taught, and the last one was instructor. For all of these methods, we had 15 trials and 5 subjects per method. So first was the video teaching. To go more into depth, the video teaching was where someone watched a video and the person in the video did a cartwheel and they were explaining the steps they did to get there and pretty much taught them, but it was virtual. Next, we have, here's an example of the final result of someone after learning from watching a video with an explanation or instructions. So watch it one more time. Yeah. Okay, so the next one was the procedure method for self-teaching. Self-teaching was similar to the last one, except it was a video, and the only difference was there wasn't instructions. So pretty much it was just a video of someone doing a cartwheel, but there wasn't any instructions provided or guidance given. And here's a video of someone learning that. So as you can see, this is our final trial, and we had videos from start to finish recorded of everyone in all of our procedures so we could compare the data and analyze it. The last one was a procedure, this one is the procedure for the instructor's teaching. I was the instructor for this experiment, and pretty much how I went about this was just seeing their first trial and again, gave them 15 attempts like for all the other methods, and pretty much tailored their the advice I was giving to them based on what they needed to work on. And we had their first and last attempt. So here's the first attempt, right here in this corner. And then here's the last attempt. So how did we compare this data or compare these results and analyze them? Well, we had 3 rubrics and we had a scale of 1 to 10 to give the most accurate number. One being, well, we had 3 rubrics, right? So this is the landing rubric, and for the landing rubric, 1 was the feet don't touch the ground when they do their cartwheel and they fall over. 5 is they landed their feet, but they weren't stable and, could have fallen over or just like stumbled. And lastly, 10 was a perfect landing, no tripping, no stumbling, and their legs ended up, or their feet ended up near their hands after they got their body over. The next rubric we had was a straight leg rubric, and straight legs are very important when doing a cartwheel because it also determines your balance and landing. 1 was the legs were at a 90-degree angle. When you think about it, that's really crooked for when you're doing a cartwheel. 5 was your legs were at a 120-degree angle, which is almost straight but not quite there yet. And of course 10 is completely straight and their legs landed near their arms. And lastly, we have the approach rubric. For the approach rubric, 1 would be no approach, no step, no hands up. They kind of just went at it with no technique. And 5 is that they took 1 step with 1 hand up, and there was some momentum, but not enough to get their legs over their body. And lastly, there was both hands up and 1 step taken, as it should be, and enough momentum to complete the cartwheel. And it's important to realize that we did choose numbers between 1, 5, and 10 to get the most accurate results.
And so for this experiment, our hypothesis was that the most effective method to learn cartwheeling would be learning from the instructor. The reasons why are that the advice would be customized to each individual participant or subject. So if they were doing really good on like the technical aspects such as straight legs, but really like failing on the approach, the instructor, Anushka, could very easily be like, try this instead, and then provide them examples from her own cartwheeling. It's very hands-on, so that includes spotting, which is a method used to like kind of move the subject's body in order to get to the right motion and also make it safer, which may encourage people to do it better or try to do it more full out because they know they'll be safe. Including that, there's also encouragement, which was seen in some of the videos where you could hear people in the background going, woo, or that was so beautiful. And so then that would also really help the participants because they feel better about what they were doing, and then they feel more supported overall in case they failed, and especially when they succeeded.
Okay, so now just for a little refresh, we wanted to see what the best method was for learning a cartwheel. So for our results, here is our first trial results for all of the 5 participants that we had, including the median. Here is the final trial results of all the 5 participants, again, as well as the median for each method's results. And here's the difference between all of the trials. Okay, so from the results, we gathered that there was a difference between the first and final attempt, which shows a lot of growth between how they first started and how it finalized in the end and how they really learned it. The video teaching had the highest median of all of the trials. The self-teaching had the lowest median of all of the trials, and the most variation was found in the video teaching and as well as the self-teaching, which does not necessarily mean that the median was affected by this. So we found that the video teaching demonstrated the most growth. The medians of the final trials and of the video teaching and the instructor trials had the same median, being 7.6, and it provides evidence for the video trial being the best method of teaching.
And so then this all comes together to create that the data collected provides evidence of the video being the better method out of the 3 to learn cartwheeling. And down here we have one of our outliers and the instructor method. And here's another look at it. And then we also have someone from the self-taught method doing their cartwheel here. Now these are pretty, they're lesser than this trial, who was taught from the video method, who's able to get her legs all the way over her body at a near 180-degree angle, while also landing stably. And then this connects back to our further development, which basically meant that our hypothesis was not supported by the evidence that we collected. Our hypothesis being that the best method would be instructor due to its hands-on encouragement and being able to tell what the participant could do better. And so this connects back to our original question, the thing we're trying to solve, which is what is the best method to learn just overall? So based on our data, it showed that the video testing had the greatest median, which showed that it had the greatest growth out of all 3, which meant that it had the greatest improvement. And connecting it back to more well-known areas of learning, such as visual, doing it, or auditory, the video would be closer to the visual because you're seeing how people are doing it, and then you're seeing how they're explaining how to do it themselves.
While we had a good experiment, there are a few things which could have been done better. The first is with the instructor we had teaching people. We did not have a professional instructor teach people, instead we had Anushka, who was good, but might not be as good as a professional instructor. So the people being taught might not do as well as if we had a professional instructor, which might make the instructor teaching method seem not as effective as it is really. The subjects we also used had different athletic abilities. Some were really athletic, some were not. This can affect our data because the athletic people learn to do cartwheels easier. It takes them less tries, they're generally better at it. This means that if a method ended up randomly getting more people that were more athletic, then it's going to seem better than it actually is. Another potential issue with our experiment is that we had a relatively small sample size. This means that there could be abnormalities in our data that might not be true for the larger population. And so this could just skew our results in some weird way. Another potential issue is that we just asked a bunch of people to send us videos of them doing cartwheels. So not all of the videos were filmed the same way. This could make it so that some videos are harder or easier to judge than others. So this might make it so that some videos get the score that they deserve, and others might not get the score that they deserve. Finally, the judges that we use to judge the videos aren't very experienced with judging cartwheels. So this could make it that as they go around judging cartwheels a little bit better at it, but that's going to change how they judge things based off their unexperienced judgments.
Also, I think it's important to add that the judges were us.
Yes.
Yeah.
Okay, now to conclude, we wanted to find the best methods for people to learn how to do a cartwheel. Now, out of these methods, we chose 3, which was instructor teaching, self-teaching, and video teaching. Out of all these methods, the best component was video teaching. Now, this shows that based off of the data, that visual teaching was the best out of all of them.
Okay, so now we have our references. Not very long because it's the video we used for the instructor teaching. And of course, with all this, some of us had to learn how to do a cartwheel. So let's see what it looks like.